A little algebraic sleight of hand today. You may recall back in Calc 1 if you saw this function. Oops. Yes. What is the derivative of this thing? So the product rule. So 3 e to the 2x plus 6x e to the 2x. Yes? Nice. This right here is the basis for the trick that we're going to show today. We are going to create a situation where we have this. We are going to create this situation. And then we are going to look at this and go, hey, what's the antiderivative of that?
3x e to 2x.
Ta-da! So, that is how we're going to make it happen. Okay? It all hinges on creating this. Just like we did when we did completing the square. Right? So when you divide by 2 and square that, do and add it, blah, blah. That we made it so that the last function, a squared, ax squared plus bx plus c. Right? Where, okay, so when you do it right, and it's just a 1 in front of the x squared, right? Then the c is half of the middle dude squared, right? Then you know it'll be a perfect square trinomial. Same thing is true here. When you have this situation, it will integrate back to something like this. Now, check it out. This guy right here, you could write that as some f of x times some g of x, yes? Clearly. Right? Which means that this is f prime g plus f g prime, yes? Right? So then the question is simply this. You're not going to have it exactly like this. So you're going to have to do some algebra. That is the cardinal rule of algebra. Whatever you do to one side, you do the other side, of course. Okay. So that's our whole goal. That's what it hinged on. This is the trick we'll do every single time. We're going to build this so that we can get back to here. Yay. And then you're like, well, okay, great. I'll buy y, Mr. Groom. Because, wait for it, today they won't be both x's. What? And so what do? We're going to freaking solve for y today, all right? But the process is 100% the same, okay? But one of them will be a y, and the rest of this crap will have some x's and garbage in it. And so, of course, we're going to solve for y. And yes, there'll be crap on the other side, but again, whatever you do to one side, this is the tricky part. Yeah.
So then, like, putting it down into that, like f prime of x, g of x.
Well, don't worry about this so much. I was just trying to describe how it works. Don't worry too much about that. Don't worry about how I label it. Obviously, that's not true anymore with a y.
Be like an f of y.
Well, it doesn't matter. Don't worry about it. Don't overthink it. If you understand where I'm coming from, the derivative of this with an x here to get to here, okay? If I build that, I can work backwards to here. Okay? Now, this is how the book will write it out. Okay? And I'm going to read it right out of your book because every book writes this slightly differently. And so when you go to look it up, I don't want you to go, well, that's not how you told us, Mr. Groom. Ta-da! Ta-da! Excuse me. Now, here's the dealio. I see a derivative of y, and I see y over here. So this is the general format that they come in, which of course could be redefined like so. Now watch me do it like this. Some of you will get pissed off that I'm doing this. Oops. What if we didn't change the sign? Just relax. We don't know what A of t is. If I bring it over here, it's the opposite of what it was on this side. Yes, but whatever. There's the general rule of the thing. Okay? Now, Donovan, I want you to understand that I have this situation here. That is, I have dy dt. I have a function of t. What kind of function of t, Mr. Groom? Like t squared? Maybe. T cubed? Yeah. Sine of t? Maybe. 2. Is 2 a function of t? Yeah, it's a constant function. That'll work. Anything right here in front of y. Plus some other function. Could this function also be a constant? Sure. Sure. Could it be sine? Sure, it could be a lot of things, right? We don't know. We'll figure it out when we get there. Right? But this thing here is a function of t. you've got a function of t, quote unquote, which may be a constant, times y. You're going to move that to the side over here. Now, this looks very similar to what we had before, sort of, because you look at this, you're going, wait a minute. This is my first function. That's kind of my f, if you will, like we did before, yes? Which means this should be some kind of a g prime. You with me on that? In other words, if that's the f, the other part should be the g prime, if you will, right? Now, I'll write of t. Actually, I'm not going to write of t. Screw that. I'm just going to write like this. I'm going to go f times, I'm going to say this is g prime, question mark. I'm not sure it is g prime yet. I'm not sure it is g prime yet. Okay? But what's the other part? Well, this is obviously f prime, right? But what am I missing over here? I need a freaking g over here, don't I? Like there's no g. I don't see any g over here because I don't see that yet. So here's how we're going to do it. We're going to have to figure out just exactly what is g, right? So that when I find it, I'm going to be able to multiply it here, here, and here. So the trick is to find out what this g is. And the way to do it is simply this. So Jacob, this is called an integrating factor. Someone much more clever than I came up with this idea. And it's like this. It is e to the integral of a of t dt. This is, if you will, that g that we're looking for. Mr. Grumman, what if it comes out to be e to the ln of t? Cool, then you're going to multiply by t. What if it comes out to be e to the, it doesn't matter. Any function can be written as e to the some power. Any function can be written that way. So keep that in mind. It doesn't really matter, but this is how you do it. So once I put this here, I'm going to then again, as I say, I'm going to multiply through by that to both sides. So it's going to end up looking, like this guy. Okay. I'm going to multiply it all the way through. And what that's going to give me is it's going to give me this situation over here that this is the product rule, that I can actually antiderivative to get back to just an f times a g. And then when I'm all done, obviously I'm going to divide by g over to this side, which is interesting because there's going to be a g on this side and a g on this side. And when I divide, what's going to happen to them? Bye-bye, kind of. Because when you integrate this side, there's also going to be a plus constant over here, isn't there? So when you divide, the g is going to cancel out of everybody except it's going not on the constant. So be aware of that. But it's going to be pretty interesting as we do them. So we will do a couple until you get the hang of her. We'll see what's up. So I'll just look up one here in the book and we'll just try it. I don't know. Let's try that one right there. Sure. dy dt. Clearly this is not separable. Yes? Yes? How come it's not separable? This is addition business. You can't get the y's over there. Yeah, you messed up, dude. So it's nice and linear. So again, we're going to rewrite it like so. And then we look at the thing in front of y. So the thing in front of y is negative 2 at this point, yes? Right? And so it's this. It is e to the integral of, and this is where most people screw this up. It's not the integral of e to the negative 2. It's e to the integral of negative 2. So what is the integral of negative 2?
Well, it's negative 2g.
There you go. This right here is that g that we were talking about. Make sense? So then we just times everybody by e to the negative 2t, which of course gives us this. Like so. Can I just pause and stare at this for? Oops, that should be y right there.
Yeah.
I've seen it. It's easier up on the big screen, you know. Now, if you're paying attention closely right here, what is the derivative of e to the negative 2t?
It's negative 2e to the negative 2t. Oh man, there it is. the same.
So, if I was a mean, horrible person, which there's a lot of people that would agree that I am, and for today's class we're going to do it this way, the antiderivative of this is e to the negative 2t times y, right? That's what it is on this side, right? Because this is my g, this is f prime, minus, this is g prime f. I should say plus, because the derivative is negative, it doesn't matter. So, God dang it. Right? And so the antiderivative of this mess is simply g times f, right? So that's the product. How do you integrate that sucker? Let's flash back to integrated 2, or calculus 2. So if you see this feller, how do you integrate him? Yeah, the u and the dv business. Yeah, the integration by parts. Li ought, yes? So this one probably ought to be this.
The negative should still be an exponent, right?
Probably would have caught that in a second. So, uv minus the integral of v du. Now what do we do? We do it again.
And then we're going to have like, then you can send the equal and substitute it.
Okay, that's fine. Merry-go-round.
Right? It's a little merry-go-round business. I'm glad you guys listen to the weirdest things I say.
There's no kissing cousins
Okay, there you go.
You need to make a book of this stuff.
Yeah, indeed. So, you end up with, you still got this mess over here from before. UV minus the integral of v to u. So it's minus, a minus, a minus, it's still a minus, a half out front. And then it's e to the negative 2 sine t, which is what I started with. Yes? So I had this to start with. Right? So if I plus this over there, I'm going to get 3/2 of them.
What is the bracket? Yeah, wait a minute.
Oops, wait, stop. The bracket, Mr. Groom, you idiot. The bracket. Thank you, good call. Distributate. Right? So if I do this, this is going to become, it's just minus a quarter. And it's going to be, that was positive out there, right? So it's still going to be minus, so minus there. There we go, right? So we're going to add a quarter to this side. Yes? So it's going to be 5/4? 5/4?
Why do you have it equal on the other side?
Where?
The e to the negative 2t.
There? That's a minus sign.
Other side.
Right here?
Yeah.
That was the original equation, dude. On these guys, you're going to go around in a circle, right? We said go around to merry-go-round 2 times and get off. So we got back to where we started from. This is what we started with.
Oh, okay.
Yeah, and now I've got what I started with. Okay? So add it over there, you get 5/4 of those guys. All right, is equal to, and on this side, it's this mess. It is gross. You are not wrong. Now there's another one. That's great. So if I times the whole this side by 4/5, right? I will end up with 2/5 negative e to the negative 2t sine t minus 1/5 e to the negative 2t cosine t. Right? All right, somebody write that down.
Yeah, I mean,
Actually, write that down. I'm going to go to the other page and bring me back the other answer. So remember, the other side was equal to e to the negative 2t times y, yes?
Yeah, I gotta write this in.
Okay, just look at it for a second. I'm not going to go anywhere. See, they're equal now. So now I got to solve for y. Well, we're home free now, baby. We're home free.
Hey, Grim, can you remind me the,
Wait, what? Wait, what's wrong out here? There's one little thing that's missing out here.
plus
I would have caught it in a second. There it is. Yeah. Yes.
what was the rule for that? Was it UV
Minus uv minus the integral of v du. And so we get to here. Now, we're going to multiply both sides by e to the 2t's. Yes? We're going to multiply everybody by e to the 2t.
Yeah.
And what do we end up with? We get y equals negative 2/5 sine t minus 1/5 cosine t plus c e to the 2t.
That's disgusting.
Oh, it's pretty, man.
Did we miss something?
No.
That's disgusting.
That's perfect.
It's
Freaking perfect.
Well,
dog.
we can real quick.
Yeah.
So, we found the integral. Oh no, this is the integral of this whole thing.
Yes.
No, never mind. Okay.
There's a lot of moving parts and pieces to these guys, and you can lose stuff real easy. So be careful. Now, I didn't tell you an initial condition, but let's just make one up. So y of 0 is 5 or something. Yes? So if y of 0 is 5, you plug it back in, what's the sign of 0?
Sine of 0 is 0.
Cosine of 0 is?
1.
So you end up with 5 equals negative 1/5 plus a constant. So the constant's 5.2, yes? Right. So if you were to go back and graph this thing right here would describe what's happening to your function over time. Okay, it would describe it very, very nicely, as a matter of fact. And so if you do that, let's look at it. Let's look at the desmos.com, maybe. Boom. Come on, go. What was it? 1/2?
Negative 2/5 sine t. Make sure you get the negative.
Okay.
Minus 1/5 cosine t.
Oh, because there's a 2 there. Plus.
Plus I.
Hey, look at the minus.
Your bread and butter? Squiggly a little bit.
So what was happening over here?
This was the same.
Over here, the e to the x part was going away quickly, and it was basically a sine and cosine function. Right as you get around to here, ooh, sorry, now the exponential takes over and drives this mess. That will happen to us frequently when we're talking about, for instance, if you're bouncing a car up and down on the springs, you're just bouncing up and down. This nice driving force is constant, but when you let go, what happens to it? Well, it peters out over time, yes? So when you let go at a certain time, it just drops off to nothing. We'll see things like that happening, where over part of the time, this is what the function looks like. Over another part of the time, something else happens. But it's pretty clear, it's right around in here where, the exponential starts to take over, right? Prior to that, it was a sine and cosine. As a matter of fact, if you went back over to here somewhere, you could straight up graph that as a sine or a cosine function either way, and just be hunky-dory with it, okay? But right around in here, the exponential kicks in and takes over. Okay? But again, I don't know what that function graphs, it's just an example. All right? Now, how would that have changed, or would it have changed, or what would have happened to it? Well, no, because I gave you an initial condition that y of 0 was 5.
Yeah, but just in that example.
Yeah. 5 and 1/5, that makes sense. Okay, let's do another. Let's do another. Yeah.
That problem took up a whole page.
Yes, they will, frequently.
Solving two-step equations.
You should like.
Mr. Grom, that's almost the same function. You're not wrong. But look at it. What we're saying is there's this portion here should look very similar to the last function, yes? Because this part's the same, so it should have that in it. By the way, it was equal to the sine function last time. Or was I shocked that a sine and cosine ended up in my final answer? No, I wasn't. This one, am I going to be shocked if there's not an e to the 2t in my final answer? I would be very shocked if there wasn't one of those in my final answer. Okay? So, again, the one with the y on it gets moved to the other side. Oops, minus 2y equals 7e to the 2t. And again, our integrating factor is e to the integral of negative 2 dt, which again is this fellow here, which is why it looks the same as it did last time. Right? Now, it's important to note right here that in a minute, it's going to look like this e to the 2t is going away. It will be back, I promise. It'll be back. But I'm going to multiply this through, and what I'll end up with is e to the negative 2t dy dt minus 2 e to the negative 2t y equals 7. That a problem for you? 7's awesome.
No, that's what I like.
Oh, okay. If I had thought about it on the last one, I probably would have just done that. But I didn't. Whatever. So the integral of this side is e to the negative 2t times y.
Yep.
The other side is 7t plus a constant. Divide it. We're going to multiply by e to the 2t, yes?
Yeah.
There's y, and then it's 7t e to the 2t plus c e to the 2t. By the way, can I just share this? This is pretty exciting. Huh? Huh? Ah, that's nice. I didn't have to, but I think it's kind of nice because they both have that factor. Pull it out, no big deal. And we said at 0 it's 3. So 7t plus a constant is oops, not 7t, Mr. Groom. That's 0, yo. So what does that mean? It means c is 3. Ta-da!
It's kind of stupid.
Oh, for God's sakes, just spit out your question.
So when we integrate
I
e to the
apologize.
negative 2d dy dt minus 2d
Yes,
equals 2dy,
yes.
how does that come out?
Dude, that is our trick, man. We have built it. We have built it, you see. If you look at this function, right, look at those guys right there, look at them.
Yeah.
What's the derivative of them? Well, this would be negative 2 e to the negative 2t times y plus e to the negative 2t times dy dt, which is what I have right here. We have built it so that when you integrate it, you get to here.
You get the, what is that word? Implicit differentiation.
It is implicit differentiation.
Can we do another example where we're not using?
Oh, for God's sake, yeah. Yeah.
Okay, we're trying to get it into a form that is
Wait, yeah, we're going to do a bunch. All right. Now, how about this one here?
that one would not take up a whole bunch.
Should I flip to
Ooh.
another page for this problem, or should I just use the bottom half?
I don't know. I don't know. Let's find out. I think this one's going to be a little larger-ish.
Every single quiz or test proves like this test is easy.
Well, I've never said that. Oh my God, you're so full of crap.
And then we show up for like the chapter 10 test, and I was like, "Oh, is the test easy?" He goes, "It's a little difficult." I was like, "Oh God, we're all worst test ever."
Whatever. He's the biggest liar ever. Whatever.
I have 92 instead of 98. You want us to try to solve it on our own?
Well, let's see what you do first, okay? So we're bringing over. We're bringing this fella over because it's the one with the y.
But you can still put that in the exponent. I guess.
What? Well, no, hold up. Well, you kind of are, yeah. Now, check it out right there. If you look at this dude right here, that's my piece that I need to integrate, right? So if I come, so it's going to be e to to the integral of negative 3t dt. What is the integral of 3t dt or negative 3t? It's 3t squared over 2, isn't it?
Yeah. You have t squared.
Why did I pick this problem? I don't know.
Plus.
No, just like that. That's your integrating factor. That's all we're doing.
We haven't been putting a plus c on.
We're not doing that because all we're worried about is we're building what we came from. That's all we're doing. We're not integrating so much as we're trying to find out. We're trying to put this in a form that we can integrate easily,
Okay.
and that's all we need.
Almost like c with 0.
So if you distribute that through, I don't think I did yet. Oops. Are you mocking me again, Felipe?
It's all good. It's just like the C thing. It's all going to fall down anyway.
Yo,
c would go away with
yo.
Whoa, what's going to happen here? Uh-oh. This is e to the 5t minus 3/2 t squared. Which is freaking gross. There's no way around that. That's just gross. Hey, let's make this a little easier on ourselves, if that's okay with you. Is it okay with you? Is it okay with you? Because I made this problem up. Okay, no, watch. No, I'm just gonna put a T here instead, just for fun. I'm gonna make this problem easier. So listen, we've run into a brick wall at this point. We couldn't go any further at that point. Okay, we couldn't go any further at that point because we would have had an issue. Just make that a 2t. That's all. Just make it a 2t. That's all. Now, listen, I made this problem up.
all my hard work.
Listen, if I made this problem up, I can change my freaking hard work. There it is. I'm done. I changed it. Obviously, if I put one of these on the test, obviously I have to make sure it works right.
You can't win and cheat.
Is there a problem with that? You say it like that's a bad thing. It's like back in the day, my dad would always go, I swear you're holding on every play. I'm like, yeah? He's like, but they only call it part down. I'm like, that's because I'm good.
That's the way to do it right
That's
there.
right. You're holding all the time. Like, you better believe I am. I'm a little fella. I got to hold a lot. Yeah. I also, in college, I found this good way. So when I snap the ball, I would drive my hand up underneath their face mask and get a hold of their neck right there. And it's like a dadgum steering wheel.
Grab, if you get both
Like-
hands like right here,
Yeah.
you can like grab them like really hard.
Except that we always taped our jerseys down with double-sided tape. And then we take the arms and we tie them down tight like this underneath. There's nowhere to grab. It was awesome. But up underneath the neck, grab on tight. Yeah, get the other one up underneath their shoulder pads a little bit. Here we go. Come with me. Here we go.
Didn't they use leather helmets when you played?
Shut up, screw you. Your grade just went down. Now, what is the integral of this side? So e to the negative 3/2 t squared y is equal to, oh my gosh, Mr. Groom. Oh, there's our u. Look at our u. Look at it. So u equals, bring the 2 down, negative 3t dt, yes? That is not what I have. That is not what I have at all. I'm going to pull this 2 out front of that thing, if you don't mind. So in other words, I have negative 1/3 of a du, yes? Is it t dt? Check it out. I pulled the 2 out front of the integral right there. So I have a 2. Oops, there's a dt right there. You can't see it. There it is. So now I have e to the u right there, yes? E to the u. And now I've got a du right here, yes?
Oh, so it's like 2/3.
So it's going to be negative,
Wait.
negative 2/3.
Oh yeah.
Okay.
Oh, I see you.
Yeah.
I'm going to write it like this. There you go. See that? All right.
Yeah.
So of course that's negative 2/3 e to the u, right? Plus c need this back. I'll sign it in there. All right. And then what do we got to do?
Multiply yo.
Multiply yo. What?
You betcha.
Hi. How are you? I'll live. Okie dokie.
Have a good day.
You too.
Welcome to Visitor. Good morning.
All right. Voila. I need an initial condition. Whatever. I feel like that would make that like 5/3 then for C, yes? I feel like C would be 5/3?
Sure.
I feel like it. Ta-da! What? Say it.
Does it equal 5/3?
I feel like it does. Because if this goes away, 5/3 minus 2/3 is 1/3, 3/3, which is 1.
Yeah.
What do you think? Not too bad?
It's really not that bad.
It's not that bad.
It's kind of like once you figure out the tricks, it's pretty.
It literally is a trick.
It's pretty linear.
I'll slide of hand.
I think it was just integrated by parts that was really bad.
I'll put that in my sleeve. Voila. Now. Okay, that's what we're doing on Thursday. Yo. Let's just learn how to freaking do them first. Okay. Now, let's try. You try this one here momentarily, see what you get. As soon as I figure out what I want to do. Ooh. Say, that's gross, but I like it.
This is
ILX.
No, it's too gross. I don't want to do that one, dude.
How many times are we gonna have to go around this merry-go-round?
Quattro?
Hey!
Hey.
What's going on? You have a question for
Oh,
me?
you think you're funny, don't you?
Oh, man.
You know how like I took stats for college credit last year? Who would know like how to put that on an application?
What do you mean? Like how to get the transcript transferred? Fine. Yeah. Go on pdx.edu. Just a search box as I want to. Order a transcript.
Thanks.
Hi. I do think I'm funny, but as my dad said, looks on everything. Yeah, I would get, first thing I do first here is I get rid of this 4. It's the first thing I would do, right? Because it needs to be in the order that I showed you for that to work out. It's the same thing when you completed the square, you wanted to have a 1 in front of the x squared, right? It was just made it easier. So same other thing. So divide the 4 out, right? That's what I do first. Whatever. All right, now make it happen. Did I make a boo boo? Did I make a boo boo?
No, you didn't.
Wouldn't be the first time. Wouldn't be the first time today I made a boo boo.
Oh, I'm just rocking.
Oh, she's so ridiculous. You have a homecoming opportunity to go.
The opportunity of a lifetime.
No, I never go home. Okay, that chick is so. She does that. He answers
Quarters
email with
over
that.
2.
Exclamation point.
3/8.
I know. Exclamation point.
It's like singular exclamation.
No, it's just like, that works for me! Exclamation point. Really? Something like that.
Maybe she's really excited that it works for her.
Well, you know
People
who
have
it
more
is.
enthusiasm.
Nuh-uh. Who? Yeah, who doesn't? Okay. Who doesn't? I don't know, I haven't tried this problem yet. It should work. Should work out fairly straightforwardly, I think. Ish. I think.
3/4
Oh, there it is.
3/4 times 3/8 is 9 seconds. Yep.
Oh, I'm stupid. It's fine, you're just dumb.
Slope field generator. So what was dy dx equal to, if you don't mind again? What was dy dt equal to? Read it to me.
4.
What?
So
What was it?
dy
No, just when you got it solved for dy dt, what was it equal to? 2/3? 3/2? 3/2?
dy dt.
3/2?
Whoa. It should be like 3/4 ty.
Bro. Isn't it? Oh, yeah. 3/4 ty. I got you. 3/4 ty.
Minus.
Hang on. 3/4 x times y. Go ahead. Minus 3/2
Say that again.
x.
Yeah, minus 3/2 x. Yeah.
Okay. So Mr. Groom is going to make a slope field of that. Voila. Do you see what it looks like?
Oh yeah.
In a minute, when I get a graph for a particular initial condition, it should have that same little whoop-de-doo to it, whether it's here or here. We'll see.
Yeah.
Keep that in mind. Okay, what's the? Oh, are we running out of time? No, we got like 10 minutes. Yeah, come on. I'm gonna freeze so you can't peek on my handwriting. See if we're right. No peeking, Levi.
Yeah, we just so and basically the integral just ends up being your integrating condition times y.
All right. So
Donovan, we get that you're better than us. Okay? Turn around and
Donovan, you back there talking smack?
I'm not even talking smack. I'm bad at this.
I'm bad at this. Whatever.
It seems like once you get the hang of these, you can skip a couple steps.
Yeah, kind of, but you got to be careful because when you do that, you end up screwing yourself up. It's been my experience, anyways.
Because like when you're transforming it.
You think you're so smart, and then whoopsie daisy. Just go for it, man. What can happen? All right. Where are you going?
Volleyball is out.
Already?
Yeah.
Oh, play good. Get a kill. What's the over/under for the number of kills you get? 10? 10?
Hit someone in the face.
Okay. I can roll with that.
negative 3/4.
Did you give us an initial?
No, he did.
I don't think I did yet.
Okay.
4/3 times 3/2 is 2.
So steps on the part that's supposed to be the equal.
Negative 3/4. Negative 3/4 times
The negative 3/8 t squared plus a constant.
I'm like trying to figure it out. Just give me a second. It'll come to me. Hold on, I'm all messed up.
See that same.
Bam! Oops. All right. So we're running out of time, so let me see what you got. See if you got this. Same as me.
Thanks, Russ. The rest I got.
Okay?
Where is it?
Oh, you said.
Okay, so I bring it over.
Yeah.
Is my integrating factor?
Yep.
Distribute it through. Is my integration by substitution business here? So I get to this.
Yeah.
Boom.
Wait, check this out.
Wait, can you go back up?
Oh. What if my initial condition was 2? What would happen right here? If my initial condition was 2, well, that would be c plus 2 is 2, which would mean c is equal to 2, and you would get y equals 2. Dude, I feel like on the slope field generator, I see a what at 2? Oh, I know. So if it started at 2, it would stay at 2. But now, what if I had an initial condition of 1? Well, then I'm going to see a deal like this going on. And if I do that, for instance, check it out. If I said the initial condition was 1, well, then this obviously is negative 1 right here, yes? And if I graph that on the Desmos, I get it 2 minus What was it? E to the what? Negative 3 halves?
The negative 3/8.
3/8? That's right. X squared.
2 minus.
Right? No, x squared. Does it say x squared?
Why are you subtracting?
Because of that.
Oh, got it. Okay.
I said if it's that. If it's that. Okay, so let's see if that looks right. That looks funny a little bit. Looks a little funny. 2 minus. Oh, because it wasn't it wasn't negative, you moron. There. And again, what does it look like? Looks like your freaking slope field, dude. And it should look like your freaking slope field. Okay? It should match up. So you should always have this idea in mind. You can always make a stupid slope field. Any idiot can make a slope field. Type it in. Boom, done. So you should be able to see, does my function match what the slope field says it should match? What you're doing.
You can actually put it.
I can't. I can't.
Two would
Make
be an
that C
unstable
value a
equilibrium
slider.
Yeah.
then? Unstable.
Yeah. What?
Make the C value a slider. Do it.
Oh, on Desmos?
Yeah.
Yeah.
Oh, okay. Wow.
Oh. Wee. That's pretty sweet. Anyway. Yeah.
We can go back again.
Oh, I'm sorry.
I like how you just do that. Check that out.
Will you go to like the original? Yeah.
Whoa.
Before you did the initial.
That's cool.
Right here?
No, up. Before all the initial conditions.
Yeah, right there.
Yeah, right.
All right. Now, tomorrow, well, you have a few assignments tonight to work on a little bit. You start working on section 1.8 stuff. You should work on a few tonight. It'd be nice. But tomorrow we're going to talk about the application of this, several different applications of it, where it shows up, and kind of see it. But it's not that big a deal. But then you'll know immediately, you're like, well, yeah, duh. And you should have an idea in your mind what's going to happen as time goes to infinity, right? Maybe the solution goes to 0. Maybe it goes to a stable like 6 or something over time, whatever it is. You should be able to see that that matches up. But again, you can always go look at that slope field and see if that looks legit. Which is why when I graphed it the first time with the e to the negative 3/8 or whatever, it looked stupid. Because it's supposed to look stupid because it wasn't the right answer. But
What did y equal in the end?
2 minus.
equal 2 plus, and then in this case, because of this initial condition, it was 2 plus, and then it's going to be 2 minus, right? E to the minus 3.
Without an initial condition, no.
This is plus c e to the 3/8 t squared.
Oh, it's an e to the u. That's not an e to the 4.
Yeah, e to the u.
Okay.
That's what this business here is all about. Off over here.
Okay.
I'm just asking if my U was a, he says, is that a Y or a 4? And I said, that's a U.
That'd be a u, bruh.
So then how'd you get the 2?
Where?
Outside the
Oh yeah! Look right here, bro. See this dude right here? See it? Do you see it?
Yeah,
Yeah, I see it.
And there's a 3 halves.
multiply that.
So you take 3 halves times
yeah.
4 thirds.
Okay, I did my mental math wrong. It came out. Yeah.
Whoops.
Okay, now I'm following it.
Anyway, so try some of the ones on the homework on 1.8, some of the simple, easier ones at start. You'll find a lot of them are very boring because they have a lot of the plus 3y's and minus 3y's or whatever like we were doing the first couple problems. All right, they're going to get messier and grosser. They are. And then but we'll see what happens. But we'll end up with a lot, not so much a lot of 3/8 t squareds, because think about that population. That thing right there is going nuts, either down fast or up fast, one way or the other, based on the constant. But we will see a lot of e to the negative t stuff happening. Okay, we'll see a lot of e to the negative 2t or 0.5t or whatever. We'll see a lot of that happening when the actual quote-unquote real world scenarios. Okay? Not so much of these, all right? You can do them, but they're kind of gross. Okay, and then like equals. We'll see some where they're equal to sine as well, for instance. So we'll actually see one like, this one's actually pretty fun. Because if you had this guy, okay, you're like, that looks like the first one we did. Not quite. Not quite. Because it's going to be e to the 2t, right? So remember, the last one we had, it ended up being sine blah, 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 plus e to the 2t. This one's going to be blah, 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 plus e to the negative 2t. So similar, and you can see what it should look like if it is equal sign. But what's going to happen is it's going to be doing this business, and then at some point, but like at first it's going to have like some of these humps going on, and then pretty soon it's just going to be this little sign. Okay? But think about that. That's exactly what happens when you're doing like bouncing the card. That's some of this. Evens out. Okay? Anyway, take a look at that tonight. See what you think. Be ready to go tomorrow. Have a good time with it.